All right. Thank you so much for being here today. I'm joined by Siva from Roche Diagnostics. So could you talk a little bit about your role and introduce yourself to people who are watching?
Hi everybody. My name is Siva Chittajallu. I'm the global head of algorithms and advanced analytics function in Roche Diabetes Care R&D. I'm responsible for coordinating a global team to address mathematical needs of R&D. In addition to staying on top of projects that my teams are supporting globally, I spend time on keeping an eye out for emerging technologies and tools, and generally try to facilitate removal of roadblocks for my team in order to do their function.
Okay, wonderful. So once again, thank you for joining me today. I'm looking forward to hearing some of your perspectives that you've got. So just to get us kind of started off, what does your experience look like with artificial intelligence? What have you been exposed to in the past?
I was first exposed to artificial intelligence in the late 90s. While I was a faculty member at Purdue University, I was using neural networks, and that was actually what I brought in as a technology into Roche. That was the reason I was hired about 25 plus years ago. I've used machine learning at Roche throughout my tenure at Roche for a lot of different use cases. Some of them are just for internal purposes. We have data in-house and we want to make some decisions about, say, for choice of materials, comparing different kinds of measurement methodologies and so on. But not just that internally, but also for creating tools that are customer facing.
Okay. Wow, wonderful. Okay, so you had a hand in this for a little while now. Then let's talk a little bit about those. What are some of the things that you have been keeping up with recently?
So typically, so just to give you a background, right? The type of projects that we're dealing with, we are dealing with building products for use by diabetics. So these products are pager-sized devices. Let's just, as a place of a frame of reference, pager-sized devices on which we put in the necessary hardware and the software in there in order to analyze the data that's coming in and to provide meaningful information so that both diabetics and their doctors can make meaningful decisions about managing their diabetes. So given that context, there are a number of things that are important. First of all, it's a device that is used to make healthcare decisions that mean life and death. So it's very important that in that kind of a situation, you are absolutely sure that the decision that you are making and recommending to the patient or physician is not going to cause any kind of a harm to the person. That's number one. Number two, the footprint of a pager-sized device with its computational capability and computational capability and memory limits us in terms of the kinds of technologies that we can use. The third thing is that we need more often than not, we need real-time kind of information. We cannot take an hour to provide a response to a question that the physician and our patient is asking. And then the last thing is the data privacy aspect. So none of the data can flow in and out of the device. It has to be all resident in the device. So given that the kinds of technologies that the kinds of machine learning that I've been involved in is primarily in terms of using machine learning for making immediate decisions involving regression, classification, forecasting, things like fail safes, which are making sure that the device is operating in a normal fashion. We off of the device, if we're talking about just internal within the Roche in-house kind of usage of machine learning, we use them for things that are related to data privacy. There's a variety of, as you may know, there is a regulation called GDPR, that was passed in the EU that governs data privacy. We have many such regulations all over the world. And so the technologies that we used to use, say, 25 years ago are not the case. So we have some emerging kinds of things that we can do machine learning in the context of data privacy. So, for example, synthetic data generation, federated learning, these are kinds of methodologies that are very important for us. Synthetic data, because you do your analysis on not the real data, but but data that is created to mask the identity of the individual and developed, and it's a synthetic data set that you can freely share with other people without revealing the identity of the individual from whom the device comes, where the data comes. So those are some of the kinds of things that we do. There's other things like physics-informed machine learning, which is a kind of a modeling paradigm that is very much hot in the biomedical industry, because a lot of biological systems, you don't understand them perfectly. You understand them partially, and you need to fill in the gaps of what you don't understand. So the combination of some insight into how the system is behaving, along with machine learning to complement it, is another kind of methodology that we use.
Okay.
There are many
Wonderful.
others, but these are some of them, yeah.
Great. Okay. Thank you very much. Appreciate all the information. You talked a little bit about kind of how data privacy is certainly a big issue. So being in the healthcare industry, there's a lot of talk nowadays about artificial intelligence or machine learning in all industries, and so that includes healthcare. But when it comes to healthcare, there is that issue of people are concerned about patient privacy and confidentiality. So how do you approach using novel technologies, whether it be AI or anything really, while still being able to maintain data privacy?
So Google, about 5 years ago, came up with this type of machine learning called federated learning. And federated learning is a methodology where the learning takes place on the edge. So the data never ever flows from the customer to a central server that is located in the company. You do all your learning on the edge. So like what Google would do is they would have a component on your cell phone that would learn from what you're doing on your cell phone without the data ever traveling back to Google servers. That's the same kind of thing that we are, and essentially biomedical companies are thinking about as well. That's one way to do it.
Okay.
Another way I already mentioned is synthetic data generation, where the real data never flows back to us, but a synthesized version of it comes back to us. But that's, yeah. So those are a couple of things. The obvious thing is really methodologies that are not particularly derived from machine learning, but derived from just general data security. Or you'll hear a lot about homomorphic encryption, where the data is actually masked and anybody can look at the data. It's like a public-private key kind of technology. It's sort of similar to that.
Okay, very neat. Thank you very much. So, excuse me. with the rise in a lot of these new novel technologies that are automating or increasing the pace of a lot of different tasks across all industries, there's oftentimes a lot of fear among the implementation of AI or any sort of artificial automation. So what are some ways that kind of you've seen that either you know that it's beneficial, or you've seen ways that help to combat some of those fears and help people understand that these things are beneficial?
Talked a little bit about data privacy. That's one of the major things that we are concerned about. There's two other things that are very important to us, and that is, I mean, among a slew of things, but explainability is a very important thing. With AI, one of the things as you go to deep neural networks or any kind of a modern machine learning tool that requires more than say 10, 20 parameters, you lose touch with the relationship between the value of a particular parameter and the the parameter value and what its significance is in terms of explaining the response of that network. And AI is hyper aware or hyper concerned that we get to a point where we build devices that have black box math that is taking place, where you get a certain result, but you don't know why the result is there. That's one thing. And the other thing is accuracy. When we build an algorithm, we need to be confident that the algorithm result is accurate. It has healthcare implications. So let me talk a little bit about explainability. One of the things about explainability is that can be used is to try to combine machine learning with traditional statistical tools. So you use large volumes of data to build a machine learning model and use the verification and validation of that machine learning model to give regulators some comfort level that nothing is going wrong, and then use very simple, explainable components that you can say, okay, well, this is a slope, this is an intercept, which is things that a regulator would be perfectly comfortable. As far as accuracy is concerned, accuracy is a big deal. So we are very conservative in the biomedical industry to, at least in our field, in our diabetes care, that we do not use any machine learning in a product-facing kind of application without seriously thinking about the implications of a problem. One approach that we do is, one of the concerns that is always there when you build a machine learning model is that the machine learning model will occasionally produce an aberrant value that makes no sense. Like it predicts a glucose of -20. Well, blood glucose never goes negative. It's always positive. So one of the things that we had done at one point is we build a machine learning model, but we cap the limits of what it is. So if it reports -20, then we automatically clip it at 30, for example. And so that way you never have an aberrant value like -20. Things like that. Clipping is a very brute force kind of a way of addressing that accuracy problem.
Okay, great. Thank you very much. So as we kind of finish out here, I've just got one last question for you. For anyone who is looking to learn more about artificial intelligence or trying to be the best professional that they can in an emerging world, what sort of lasting advice or summary do you have for them from here on out?
So I think as you know, Alex, the field of machine learning is changing so rapidly, and so in order to really follow that rapid pace of um, changes or evolution of that machine learning, you have to start with a solid foundation. So I would always recommend that people uh, don't start out with the current latest and greatest kind of a thing, and not really on learn about the statistical foundations of machine learning, for example. Make sure you learn the statistics of machine learning and then start with some ground level kind of machine learning concepts before you go into. You don't want to make it essentially be cautious about trying to uh, be a person that just turns the crank. You know, a lot of current tendency would be, hey, there's this fancy tool, I throw in the data and I come out with a result. Try to get beyond just using a tool, but get to the level of understanding from a statistical machine learning kind of a background to be able to say, here's essentially what's going on. You have to have some sense of what's going on. Don't
Course.
use it purely as a tool.
Right. All right. Well, thank you. That was some fantastic advice and a wonderfully refreshing perspective on artificial intelligence today in the world. So thank you very much for joining me today.